Hello, everyone. My name is Rory Preddy. I'm a principal advocate for GitHub. Today, we've got a really exciting session. We're going to talk about agentic design patterns. Now, I had a dream that I could actually go in and recreate the movie, the 1999 movie by Warner Brothers called The Matrix. So I rewatched all of the films and I said to myself, Rory, you're the author for LangChain4j for beginners, the tutorial. You should be able to actually understand how this works. So in collaboration with the LangChain4j contributors, I actually went in and I analyzed the rules for what an agent is. And I remember a quote from Morpheus, one of the main heroes. Their strength and their speed are still based on a world that is built on rules. So what are these rules there? And I said to myself, wait a second, instead of rules, maybe they react. And via the patterns that I'm going to show you today and the reaction of those agents, then I could build the game. So what is an agent? An agent reasons and acts, react. And that's called the react pattern. And an agent can be many things. You can get cloud-based agents. We're going to use local agents that use a large language model for its processing. And in that, you can also remember your state and you can collaborate with other agents. In LangChain4j, you can see that we actually have many different layers of the agent. On the top of the layer, we have the agent. It has a system prompt and the prompt you're going to send it. All the time that can read from agentic scope. It's like an in-memory memory that it has, though. Then it's going to call your LLM, large language model. And then in that case, we're going to use GPT-5 Mini. And then we're going to have tools. In many of the agents we're going to show today, they use tools. And also, you can use tools to do calculations, web search, database query, and then you're going to output your results to the key, and that is going to be shared with additional agents. Now, to get started, you add your dependencies, you configure your LLM, and then you define your agents, and most importantly, you choose a pattern. Now, what are these patterns? They're actually in 3 different categories. You get tier 1, tier 2, and tier 3. Tier 1 is a workflow pattern. Think your classic language lexicon, your if, then, else statements, and that is the same as sequential, parallel, loop, and conditional. And you can kind of build your own kind of program, agent program from that. But sometimes you also want to go a little bit further. You want the LLM, the large language model, to help you a little bit. And you do that with the supervisory, and maybe you want a human to help you, and that you do that with the human in loop for the agentic patterns. Finally, the tier 3, the planning patterns. This is where it really gets magical. You have goal-orientated agentic pattern, which basically draws like a roadmap of where it's supposed to go to optimize the path of which agent to call at what given time. And then you have the P2P, which is the emergent behavior, which allows you to actually go agent to agent and only call each other once the requirement to call that agent is actually met, though. So we're going to go through each one of these agents, and we're going to go through an example for each one of them. At the same time, we're going to use the agent pattern showcase, which I'm going to give you the access to and the source code for that, and which is going to allow us to run this live. So the first one I want to show you is the sequential workflow, the chain pattern. You've got the creative writer, the audience writer, and the style editor. And each one of those is going to take a story and then daisy chain it along as it progresses. So the creative writer is going to generate the story, the audience editor is going to adapt for the audience, and the style editor is going to polish the style. So let's go into our showcase here, and we're going to go into a sequential workflow. And you can see that if I just execute the pattern, it's write a fantasy story for teenagers in a humorous style. What it's going to do is going to call the event log. And what I've done is I've wired all the agent events to a WebSocket listener. So we can see as it goes through the events here, what and who is calling. So it's already calling the novel creator. Now it's actually going to call the generate story, and it's going to go and go through each one of those. And I've also got the actual code here. So if I go to execute sequence, you can see there the sequence, it's pretty simple. We're going to use the agentic service there. So we're going to go to agent builder, go create the writer, go create the audience editor, go create the style editor, and then just add them together. We're going to go the sub agents, writer, audience editor, and style editor. And then the output key is going to be story. We're going to execute all of that with the Agentic scope. We're going to pass it in topic, audience, and style. And if you see here, let's go back there. We've got our results. It's coming there. We've got right at the end of it, we've got edit for style. And if you remember, that's the last little agent it's going to call there. And this takes about a minute or so to execute there. And while we're doing that, I just want to remind, there we go. 77 seconds. By the time tripped over the school crest, and it goes through all of that, and it's already been edited for that audience. So that's great if you want to do sequential. But what happens if you want to do everything in one go very quickly? So let's go into parallel workflow here, and we can see plan a romantic evening with movie and meal suggestions, execute pattern. Now we've got a food expert and a movie expert. Now both of these are going to be called at the exact same time. If we look at what the source does here, execute parallel, and if we see there, we just got a, let's go there, we've got an evening planner agent there, and that is just if you see here, let's go evening planner agent there. We've got parallel agents there. We've got the food expert, the movie expert, and then we've got the evening planner agent there that's just an interface that just says, go run these things at the same time. And it's actually going to then go in and execute that and run them at the same time and create the plans for that. So really quick in comparison, that took 77 seconds for the sequential. Look at that, 8 seconds. And then we've got the evening plans, but they're not really the same. Movie before sunrise, and then meal seared filet mignon. It's just meant to just, here's a million agents, go run them and execute them at the same time. So that is the parallel and sequential, pretty easy to understand. But what about the loop workflow? So it's the same with the sequential. Write a story about dragons in a Shakespeare style. We've got the creative writer, and then now we're going to style it, and we're also going to edit it, though. So what's going to happen here, if we go back to the editor here, we're actually going to go to the loop pattern, and it's going to have the creative writer generate a story, and then the style scorer is going to send it to the style editor and redo that entire story every single time it gets a score less than 0.8. So let's go look at the code quickly here, and let's go into here. We want to go into the pattern service, and don't worry, I will give you all of the code at the end of the session here. And then we've got a loop here. We've got the creative writer, we've got the scorer, and then we've got the style editor. And all we say here is we loop it. And we say just loop exit condition that the score has to be greater than 0.8. And that is actually the loop builder, which is part of the libraries that are given to you by LangChain4j. And it allows us to actually loop through that, maybe indefinitely, but not indefinitely, because we've got a max iterations of 5. And this is pretty important because else it will go on indefinitely through that, though. So let's go in and see our loop. And it's going to take a little bit long because, it can take 5 times there. Let's just see. Oh, it did come back there. We got a score of 0.9. Whoa, that's a high score. And it gives me my story here. And you can see here, it's going to go into the style writer, the generate story, and then it's going to start to score style. And then it's going to say, okay, the initial score, because we haven't even got one yet. And then we're going to store it as score style there. And then we've got 0.9. So everything is exactly perfect for our styling. And that's our loop, though. So once you loop, you also want to do an if-then-else statement, conditional routing. What are the symptoms of diabetes and available treatments? And you want to send it, you want to get a category, and then see, do I want to send it to medical, legal, or technical experts? I'm going to execute that pattern here. And it's pretty simple when it comes to the conditional route. Think of it like a compiled language. You're going to take your condition, you're going to say your router, what is my router here? And I'm going to get my conditional agent there. And then it's going to say, here's your categories, and then go in and categorize as a legal, medical, or technical. And then once I have the category router, I've got my experts, legal, medical, technical. I've got my if statements to say that if you get a category back that is medical, go call the medical experts. And then watch this. I actually compose the router and condition in one sequence. And I'd say, sequence builder, run that, though, and execute both the router agent and the expert agents, route them, compile them, and run everything for me in one little go. So let's go back here. And it did come back there. And it gives a disclaimer. I'm not a medical expert, but this is general information and not medical advice. That's great. And then you can see there, let's just go a little bit higher there. You can see it rooted to on the conditional to the medical though. So those are the principal kind of lexicon language specifics for the agents. Let's get on to the more meaty and the magical one, the supervisory pattern. So if I go into here and I go into, and we've done conditional, and the supervisory pattern says, okay, cool, I need to do a transfer. Which one of these can do a transfer? I need to do an exchange. Which one of these can do exchange? And then credit agent here. And the banking supervisor is going to actually choose which one, then look at the results and say, I like those results, or I didn't. Go do it again. So let's go into the AI agents here. Let's transfer $100 from Mario to Georgios, then convert $50 to euro. We're going to execute that. It takes about 30 seconds to go through. Let's go look at the source now. So if we go into the execute supervisor, now this is where it actually gets very interesting, because you've got your withdrawal agent and you've got your credit agent. Let's just close that there. You've got your credit agent. Now what it does, it passes in tools. So the tools there, if you see there, the credit agent and withdrawal agent, they both have bank tools, but the exchange agent has exchange tools. And what these tools are, if I just click through here, they're just a very simple in-memory map here. But the novelty is when you want to credit someone, you have to annotate it with @tool, and that's a LangChain4j. And what that does, it actually creates the standard LLM tooling interface. And you've got tools for withdrawal, for credit, and also exchange. You've got exchange here. And the LLM will say, do I have a list of tools that I want to execute certain commands with? Yes, I do. I have one that is exchange, and I've passed it to my let's go here, the exchange tool, and it allows me to go in and look at which tool to use. And then I've got my supervisory agent. It says supervisory builder. Go call all of those sub-agents with your magical LLM power, but use a summary there. And a summary basically says, after calling all of them, just return a summary of exactly what happened. And here we go. It transferred $100 from Mario to Georgios. Mario withdrew $100. And that's his new balance. Georgios credited $100. That's his new balance. And then I converted 50 US to euro, and the result was 46 euro though. Great way to actually do this. And it's a great little magical way to do that. And human in loop is kind of like that also, because I am an LLM also, and I've got to create a horoscope for me. It's got a built-in human in loop feature there. And okay, I'm going to go Virgo, and then it's going to go submit a response to an agent there, which is you got your proposal agent, your human, and then execution agent. It's going to execute that with the code. Let's go check the code there. Human in loop there. Let's open that up there. And we've got our agent builder, Zodiac extractor. It's going to go into, let's go into that. The Zodiac extractor, your Zodiac sound extractor, analyze the user's message, determine if they and given that. And then you can actually go through that, the horoscope, and then it goes and generates a horoscope once it actually gets the users there, and then executes it there. Once you have the human has reviewed the proposal and might have feedback there also. So we got that. It does use different agents there to do that. Let's go see the next one, which is the fancy. So let's go human input, the GOAP, goal-orientated action planner. So what that does, it actually creates a route. You know, the traveling salesman is a classic problem where the salesman has to go to all of these destinations, all of these locations, all of these places, and then you have to create a map for that. So this is very similar in that it creates a graph of what each agent needs for its input. So for example, the itinerary planner needs both route and attractions. Now, route is coming from the route optimizer, and attractions is the attraction finder. So the easiest route would be from city parser to attraction finder to route optimizer to itinerary planner. At the same time, you can run distance calculator and attraction finder at the same time. So it looks at the cost and what to do with that cost. Let's go execute it there. And let's go back in there, and let's go back into our go-oriented program. This takes a little bit long here. Plan a trip visiting Paris, London, Rome, Berlin, and Barcelona. I'm just going to take that out just for that. And let's go in there and Rome. So we're going to execute that pattern there. And what it's going to do, if you see here, it's going to go, okay, what do I need to do first? Okay, the first thing I need to do is I need to go get the cities. I need to go past the cities, and you can see that it's going to pass the cities. And then now it's already going in and finding the attractions. So if you remember here, city passer, attraction finder, and then we also need distance calculator. So let's just see, it's got, let's go here, calculate distance. So it's already past the cities, it calculates the distance, and now it's finding the attractions, and now it's optimizing the route. So if you saw here, we're going to do route optimizer, and then we're going to finally, right at the end, we're going to itinerary plan. So let's go into here. We've got the plan. It's busy doing that right now. So we optimized the routes already. We're busy planning the itinerary, and the planning and the itinerary is actually the most difficult part with the most computation, because what it's doing, it's taking all the information that you have, and then it's saying right at the end, because the graph has the data right at the end, I'm going to now execute the final stage of the graph though. So pretty quick. This is using GPT-5 1 mini, but I did go in there and I said to myself, let's just do Paris, London, and Rome though. So if you go into your optimized route, it says 3 cities. Any Hamilton tour uses only 3 pairwise legs. So both possible. This is so funny to read how the LLM talks though. And it's actually going to, I think I can actually not fly here. So if I see here, Paris, London, and Rome. Now I think I'll probably have to fly to Rome though. So let's wait for that to execute. It does take a little bit longer than the others here. And then while we're doing that, let's look at the final pattern for the P2P. This is a decentralized method. Imagine a swarm of agents that are just popping up left, right, and center that can just have an emergent behavior. This is if your input is suddenly created and you're sitting there polling for your input, start actually executing. So you've got your literary agent. There's no central controller, and then that is going to go in and call the hypothesis agent once the literature is created. The critique is going to say, I like or don't like that hypothesis. The scorer is going to go in and score all of that. And then the validation agent is going to go validate that where necessary. At the same time, we're going to get a scoring of greater than 0.75. So let's go back into here. We've got, there's our Paris. We've got, it took 142 seconds, and it gives us the itinerary. Right at the end, I can actually see how long it's going to take. 7-day itinerary. There's the emergency numbers. It goes through everything actually, and then gives it a score also of what you want to actually get though. So great way to actually see, can I go on a trip and how easy is the trip. So the last one obviously is peer-to-peer, and we're going to say research the effects of caffeine on cognitive performance. We're going to execute the pattern here, and it's going to create literature. It's going to create a hypothesis. It's going to critique it. Going to validate it, and then it's going to score it. And then each one of these agents here, if you see, as soon as let's go here, as soon as one of the agents is triggered from the research, it actually goes in there and says, wait a second, I'm ready to start. So let's go into here, and we've got our, no, not GOP, we want our execute P2P here, and then we've got our literature agent, but look at what we've got here, output key research finding. And then that is going to output key hypothesis. So if we go into our hypothesis agent here, and let's go into there, you'll see there that we're actually looking for research findings. And we're going to actually wait and trigger based on those research findings. And you can go through that with the critique agent. It's going to look for a hypothesis. For the validation agent, it's also going to look for the original hypothesis, but it's going to output critique here, and it's going to go through the scorer agent. There is also going to score it, and it's going to give you a final score and also the hypothesis. So if we look at the execution service, right at the end there, we've got our little custom planner here. So it's a P2P planner from the LangChain4j library there, and it just says there, go read the state and go make sure that the score is above what the threshold score is though, and make sure that the max iterations is 10. So there's a lot of features inside the LangChain4j agentic services that allow you to trigger and to write your own custom model workflow, the planner workflows, and allow you to create emergent behavior like we have here. And if we go back to our little example here, there we go. Final hypothesis: in healthy adults, a single acute dose of caffeine, 200 milligrams, which is a lot of, actually, that's a lot of caffeine, will improve working memory performance. And it'll give you the scoring there, 9 out of 10 out of 1 though. So target score reach. This is 5.1, GPT 5 mini though. So, you have to take it with a pinch of salt. Maybe a little bit higher if I used a stronger LLM. So I think I've got enough of my examples. Now I've got and more than enough information to create my combat arena with Agent Brown, Jones, and Smith. How am I going to attack Neo? Well, first of all, I want to attack them in 3 different ways: sequential, parallel, and auto battle. Auto battle is going to use the loop. So sequential, all of the robots, the agents are going to attack Neo one by one. And then parallel, they're going to attack them all in the same time. And then auto is going to do all in the same time, but in a loop though. So let's go into our AI agents. Here's my agent Smith. Just want to hit refresh here, and it's running on a 0. Don't worry, I am going to give you the URL so you can play around with that. Now, if I go Neo's the one and I hit fast, you'll see there that I've got the sequential, the parallel builder, and yay, Neo 1 here. We'll go look at the code here. Let's go file, open recent. We want to go into Agent Smith. And if I go into the parallel code here, pretty simple, the combat service here, run parallel, very similar to what we showed you there before. Here's the parallel agent, and then we've got the output scope there, sub-agents Brown, Jones, and Smith. And then we can actually see there that we've got parallel combat there and parallel combat.class. We go in there and it's going to run them, fight all at the same time. And we're going to run them there. And let's just see if we've got that there. Okay, so Neo wins there. But what happens if I actually go and reset this and I run it auto 5? I've never won this live on air though. So let's just see if we're going to do. Okay, so Neo won the first round. Now this is randomized, but it's also at the same time. Oh no, he lost in the second round. I'm sorry, guys. I didn't really predict that though. But the matrix is restored. Neo didn't actually make it though. So this is what I wanted to show you today: the different ways that you could actually do that, and the game that I created. So in summarize, sequential, great for simple pipelines with clear steps. Parallel, you need multiple perspectives fast. Loop, quality is critical. Time is not. It can loop it multiple times, can take the day. Conditional, it compresses it and then executes it. You need different inputs and different handling. Supervisor, it's your friend. You can add a complex task, unclear how to break them down. It will do that. It can do banking. Human in the loop, listen, I can do banking also. Ask me a question, I can help you with that. And then you have the custom ones, GeoAP. You need many dependencies. You need that optimal path, that traveling salesman path. And then for P2P, the creative brainstorming collaboration. You want the source for the game? Here it is, aka.ms/the matrix. And there's the repository. Also, you can go around and see exactly how it did it. And it also has the ability to deploy to Azure on a container app. You want the live dashboard? You want to go play around with? There's the app, aka.ms/agent-patterns. Play around with the executor. It's running on Azure, and there's the repo for that. I want to remind you about the LangChain4j for beginners. If you don't know what RAG, tools, MCP, and agents, you want to know about the 14 core patterns of prompt engineering are, go look at that. I'm the author, and I also got the contributors for LangChain4j to assist me with that though. And then finally, I want to remind you that everything I've just said here is actually on a video series, including the Agentic Patterns and also the LangChain4j for beginners. You can go to LangChain4j-reactor. Thank you so much. You've been a great audience, and I look forward to seeing what you're going to build. Cheers, everyone.